everyone, welcome to PeopleSys Tutorials. Today we are going to learn how to use NodeMCU Amica board. It's available from our online store peoplesys.com. You can see the link below in the description. So let's get started. First of all, you will need to install the driver for CP2102 chip which is present on your board. Without it, the board will not get recognized by the Windows. So for that we will head to Google and just search for CP2102 driver. The first link will be from SI Labs and this is the one which we need to install. Go to this link and since I have a Windows 10 64-bit OS, so I will be selecting this, and but you can select based on which Windows version you have. So I'll download this. So after downloading, you can extract it to some folder. I have extracted it here, and as I told, I have 64-bit installation of Windows, so I'll be installing this and run as administrator. The fact is I already have it installed on my PC, so I'm not going to do it again, but it is a straightforward process. Just you need to follow the options provided in during the installation, and nothing fancy about it. Okay, so once the driver is installed, we need to connect the device with a micro USB cable to the PC, and I will keep device manager open so that we can see when it gets detected. So I have connected the board now, and now you can see the one of the port is enumerated, which is COM port 4. So our device is detected. So the next step is actually to start communicating with the device. So for that we will use putty. So in putty is a serial terminal emulator, basically used to communicate between the serial ports, and there are other uses. You can do SSH and all other things with this, but for the time being we are going to use it for serial communication. So go to the serial tab here, and since our port is enumerated is COM port 4, so we'll change it here to COM port 4, and the default baud rate I am going to set 5115200. Data bits 8, stop bits 1, parity none, flow control none. And I will go to the session here and click on serial and then say open, and now you can see that some of the characters are already there once we open the board. So okay, don't worry about these illegible characters, because those are the ones which were sent by the initial firmware boot, and the baud rate for that is 74880, but we have set it to 115200. So basically what happens is after the firmware boots up, it changes the baud rate of the device to 115200. So right now we are at 115200. So we will try to see whether the board is responsive. So for that I'll type just an AT command. So just by typing AT and pressing enter, you will not get any response from the device, because it expects a line feed also. So to send a line feed, after pressing enter we'll press Ctrl J, and here it goes, it gives you AT OK response. So you can check the other AT commands from the expressive AT command reference manual, and you can use this device. So let me increase the length of this window. So that command is AT plus RST to reset the board. So I will press enter and then Control J. So you can see that it has again printed out some stuff. Some of the stuff is fine and the later stuff is not clear. So here the firmware is printing out some of the useful information, that some date and SPI speed is 40 megahertz. QIO mode is there for SPI, and SPI flash size is 32 mbit, and the flash map is 512 KB plus 512 KB. So this is the more useful information which we will need in later while we are going to flash the device with the new firmware. And other thing is the firmware which is right now on the board by default is pretty old firmware and is not of much use, I guess. So we will quickly be moving to the RTOS SDK, and we will be providing more tutorial on that about how to use it and how to flash and all other things. So keep tuned to our channel.
Wherever I go, wherever I see, I remember you. If you remember